In this video, we're going to be finding probability using Venn diagrams. So up here in the corner, I'm going to create a small Venn diagram. We're going to label it A and B. Now, a little bit about notation. So we've labeled the circles of the Venn diagram A and B. We can label them whatever we want depending on the situation. What I like to do is, when just given this Venn diagram with A and B with no real world context, I like to think of A as athletics and B as band. So we can walk around and ask our friends, hey, are you in athletics? Hey, are you in band? And we can kind of maybe get a little bit real world application there. So it's not just thinking about numbers and what ifs. So some notation is this capital P stands for probability, meaning our answer is going to be a fraction, a decimal, or a percentage. And all these numbers have to be less than or equal to 1, which is the same thing as 100%. So if you get an answer of 120%, you are incorrect. You can't have a probability of more than that. Now, some other notation, instead of the capital P, we can have an N, which basically just stands for number. So how many people are in group A? That's what this is asking. And then the last one is this capital U, which means our universal set, which is the same thing as just the total. So we're just going to go through and talk about a few probabilities with this Venn diagram. So the first thing we can do is ask ourselves, what's the universal total, or the universal set, which is the same thing as the total. And we look at this. Now when it has the N in front, it just wants a number, a whole number, not a fraction, not a decimal, not a percentage. This is not probability. This is how many people. So in a universal set, you just add up all the numbers you see one time, which is actually 16. So for this Venn diagram, this survey, this situation, we asked 16 people, or had 16 points of data that we put in this diagram. And this is what's going to help us for the rest of the time. Now I can ask how many people are in group A. Now, a very common thing is that people sit there and go, oh, that's just 3 people. But is it? No. There's actually more than the 3. Group A includes this entire circle. So really, Group A is 3 and 4. So that is 7 people total that are in Group A. The reason we have to think about it is that 4 in the middle. They're in Group A, but they're also in Group B. But I didn't ask that. I asked this question. How many people are in Group A? I don't care what those 4 people in the middle do in other groups. They're in Group A, meaning I have to count them in this question. If you want to bring that into a real world, A for athletics, B for band, there are 4 people that are in both. That's possible. But if I ask how many people are in athletics, those 4 better be counted because they're there. They're doing the work. Count them. Now, if I say find the probability of A, how we do that is we just find the number of that happening and divide it by the universal set, or the total, which we just found that was 7 out of 16. Simplify the fraction. You can write it as a decimal or as a percentage. And you don't have to write down this step. You can just go straight to the answer fraction if needed. couple other probabilities that we can find is now we're going to compare both groups. This upside down U stands for the intersection. The word I want you to say and think about is the word and. So how you would read this is, what's the probability of A and B? What's the probability of them being in both groups? This one's kind of straightforward. It literally says intersection. So look at the intersection between our two circles, which that means there are 4 people there. Since it is probability, we are going to divide it by our universal. Simplify your fraction. Your answer can be a decimal or percentage as well. Now, a very similar probability here. Instead of an upside down U, we're actually going to use a U now. And this one stands for union. Union. See how they kind of look the same? Now, union, I want you to think of the word or. So this is asking what's the probability of being in group A or B. Now, the word or in this context is very weird to understand logically, because we're asking, are you in group A or B? But this could also mean both. So I walk up to these 16 people and I ask you a question. Are you in athletics or band? Yes or no? How many people would say yes? It would be those 3 people that are just in group A. It would be the 7 people only in group B. And it would be the 4 people in the middle. The reason being, if you walk up to those 4 people and I ask, are you in group A or B? Are you in athletics or band? They would say, yes, I'm in both. I don't care which one you're in. I asked a yes or no question. Are you in A or B? Yes or no? They have to say yes. So they're included in this or union question. That would be out of 16 people. So 14 out of 16. Simplify that fraction, decimal, or percentage. The union is one of the more difficult questions to think about because we always forget about, I don't care what else you do, just answer my question, yes or no. Now, a little bit more notation is this apostrophe. The apostrophe means not. So this is asking, what's the probability of not A? That's what that apostrophe means. Just kind of negates everything we've talked about, or everything about A. So you kind of have to think backwards. How many people are not in group A? Well, let's count. Those 2 people aren't. Those 7 aren't. Are those 4? Yes, they are in group A because they're in A's circle. So we only add up 2 and 7. These are the only people that aren't in athletics. They're not in group A. So that'd be 9 out of 16. You can write the decimal or the fraction. now we can go ahead and take this probability a little further. Not only can we just talk about not in a group, but we can talk about not in multiple groups. So what's the probability of A and B, and they both have a not? So what's the probability of not A and not B? If we think about this symbol here is our intersection, which means and. So any person we talk about, any number we write down, cannot be in group A. So the 7 and the 2 are not in group A. But they also cannot be in group B. They can't be in group B. So that means only 2 people are in that category, because the 3, 4, and 7 are in A and B, are in A and also in group B, or just one of them. So that's 2 out of 16 people, which is 1/8. You can also write the decimal or the fraction. We can move on with that as well. We can also talk about there being the probability of A and not B. Only one of them has been knotted. So this means that the groups have to be in group A and cannot be in group B. So let's kind of think through this. These people are in group A. So those are the ones that we're going to be looking at. But now we got to talk about and. Well, what about group B? I said we can't be in group B, which means those 4 can't count in this case, because even though they're on group A, they can't be in band as well because it conflicts. So in this case, we are only talking about the 3 people out of 16. And it's the same type of logic if we were to put the not on group A like so. But in this case, oh, I'm sorry, I forgot to write the 2 there again. But in this case, it would be 7 people out of 16. Now with these probabilities, we also have to talk about the union between them, the or. Remember, the or means one or the other, or both. So let's go ahead and circle everything we know that focuses it. So let's just look at not A. What numbers are not in group A? And that's the 7 and the 2. So those are going to be used. Let's just look at B. What groups are in group B? That's the 7 and the 4. Okay. Or both. This one we've already covered, because with the both, that would only be group 7. So these 3 numbers are what we're going to have. So that'll be the 4, the 7, and the 2 out of 16 people total. Which is 13 out of 16. decimal, or fraction as well. Now, with the not symbol, it can get a little bit complicated because we can also find the probability of two things happening, and then outside those parentheses, we put the not. So basically, all we're going to do is focus just on what's in the parentheses, and then we're going to not and do the opposite of it. So in this case, what's the probability of A and B happening, of both of them? And we've already talked about this question, and that'll be the 4 here in the intersection. And since we're negating that, that means it's everything else. This not means the opposite. So this will be the 3, the 7, and the 2. Don't forget about that. So that's 12 out of 16, which is 3/4, or 0.75, or 75%. Now the last probability I want to talk about is this one. This vertical line means given. So what's the probability of A given B? What this kind of means is, what's the probability of A happening if you already know B is happening? And there's a formula that we know for this. How we figure it out is it is the probability of the intersection, or the and, between those two things, divided by the probability of the given, or what's second, okay? And instead of doing probability, we can also write the number of it. It's the same thing. So let's kind of go through this. Now, if we use the probability of A and B of the numerator, there are 4 in that intersection. And now we get to divide it by B, the number that's in group B. And we just go through that whole circle, and that's 4 and 7. So out of 11. That is the probability. Simplify your fraction, or a decimal, or a percentage. And that is the probability of A given B. Now the reason why we can just use the numbers instead of the probability is because if we use the probability, the intersection is 4 out of 16, and just the probability of B is 11 out of 16. Dividing fractions, we know to multiply by the reciprocal, and we see those 16s just cancel out. So we're just saving time by using the numbers anyway. Now you might see on an assignment or a question where they have the probability of the reverse, of B given A. And it's the same formula, you just have to rearrange it. So you look at the probability of the intersection divided by the probability of the given, which is always the second one. So it actually is going to be a different number than the one before, but it follows the same process. Now, kind of question, is this probability the same thing as A and B? Yes, it is. So it doesn't matter which one's first, with union or intersection,